Hi, Mr. Novak here. I'm going to walk you through Chapter 5 Quadratic Relations, focusing on our TI-CAS calculator. From evidence from our linear equation test suggests that some of you are not using the full functions of your calculator, and it is a brilliant piece of equipment you've got there. So let's look at what we have. Quadratics in the real world, it's everywhere. It's in nature, it's in engineering, and it's in graphics. And so it needs to be described mathematically. So a graphic or parabola has five main features, and you can see them there. We did this in year 9. And they are, of course, the y-intercept, where it cuts the y-axis when x equals 0. There it is. When x equals 0, we can find the y-intercept. The axis of symmetry. In actual fact, the actual symmetry is best found by, if you know what the turning point, it has the same x value. There it is, the turning point xy. We have via completing the squares or by looking at it. We have the x-intercept, and we've been focusing a lot on that when we use the solve for y equals mx plus c equals 0. That's when y equals 0. And finally, in parabolas, we want to identify if it's a minima or maxima, and you can just simply look. So that's what we're on about. So looking at using our calculator, we have the calculator page is one option. To save us the time, we might do what's called define the function. In other words, we don't want to write this out lots of times, so we can use the defining. One thing you will find, it gives you the exact answers. So if it's a surd, it will leave it in surd form. And you can get the maximum because you can't look, but you can get it from the coefficients. The other option, of course, is to graph it, which makes a lot of sense when you're trying to identify those key points. The disadvantage of that, of course, is it only gives your answers in decimal values, not in surd form. So, but it, as I say, easily identified. So let's have a look at the calculator page. So there it is, an example of the calculator page. And the first step is to define the function. In other words, I don't want to write that out lots of times. So I'm just going to call it, give it a name. And so we're going to call it f1 of x. So let's go to that now. Here we are. So we have, we'll go to page 1. I'll clear all this. This is some useful things. Action, clear, history. And let's start again. So I want control. There's that unique feature of a colon equals. And so, but we first need to say what we want was f1 is the name, and it will be in terms of the variables x, show brackets, x, close the brackets. Oops. And now we can define the equation, which in this case will be x squared minus 2x minus 3. Press enter, and all it's saying is it's stored that as f1. So now let's have a look at our first feature that we want to look at, and that is we want to look at solve. Solving actually will tell us for when y equals 0, in other words, when we're going to find the x-intercept. And that's simply menu 3.1. And we're going to use this button called vars. And we'll see what happens. So you go menu 3.1, you recognize, or what you should recognize, would have made linear equations very easy the other day. But instead of writing out that function, all we have to go now is var. And we know we've got f1. It was in the pronumeral x. And here's the important step. I often forget myself. That's why I would have it written in your summary book. Equals 0. In other words, when y equals 0, we'll find the x-intercept, comma, and we're solving for x. Press enter, and it says it cuts the x-axis at -1 and 3. Another option, of course, could have been simply going menu 3, 4. Again, vars F1 X. I don't think, I'll see if we can just press enter. No, we do need the comma X there, comma X. And it gives you, but in bracket notation. So it's as I say, a notation that you're going to have to start learning to. They're definitely curly brackets, not round brackets. You don't want to confuse them with coordinates. So that's why when you're moving on to methods, you need to be very particular how you write things. The next thing we want, of course, is we want to complete the squares, and that will help us to find the turning point. So that's menu 3, 5. So let's go to menu 3, 5. Complete the squares, and now you can start to see the advantage of having defined it. I think we have to do it. I don't know. Maybe we can just press enter. No. Eventually, you might just think, I might just put comma X every time. And there it is. Now, all we have to do is, for that bracket to be equal to 0, X must be 1, or the opposite of -1. So that's 1, comma, -4. Try and remember that. That's the turning point. We'll see that on the graph page. Next few steps, of course, are the y-intercept. So easy. And while I'm on this page, I want to also do the coefficients of the polynomial, though it's really obvious. It's 1, -2, -3. Sometimes it's useful. You'll see the use if you do all the exercise that I ask of you. And this often gets asked, what degree is the function? In other words, the highest power in this case is 2. So that's simply menu 387 and menu 388. So really basic things. You don't have to remember this. Put it in your summary book. So let's go to the next page and just quickly do those. So we wanted to go fars F1. We want to find out where it cuts the y-axis, and it was -3. Remember the constant. And the other two features we wanted to know is the coefficients. So that was menu 387 vars F1. I think we don't have to just put the X. I don't think we have to do the comma X. No. And the other one was menu 3. Always much easier to use the keypad. Vars F1 enter. Again X enter, and it's degree 2. So very useful. And the questions I've left you will also show you some examples where you'll have it in third form, or where these coefficients won't be self-evident. The other option we have now is to look at using the graph. And of course, to do that, by the way, it's the 0 one. Remember, graph, it only gives you decimal values. So if you need exact, you need to go there. We can actually select the equation using Control G, and we use the points of interest using trace, which is menu 5.1, and the axis of symmetry, which you should know that we can draw a vertical line. One thing that was really done badly in the linear equation by menu 3312. So let's have a look at can we produce this page. So let's have a go at that now. So we go to our graph page. Remember, that's the graph page there. I'll stay with the current, which is page 2. Make it page 3. Okay, I'm going to go for a new page. There we go. Now F2 is what we don't want. We want to go up. So cursor up because we want F1. And there it is, automatically done for us. Press enter and it's drawn. So remember, points of interest are simply menu 5. Menu 5, and 1. Menu 5, 1. We cursor left and right until we get to some key features. When it says that statement, in this case 0, press enter and it will record the point. Don't try and move that point now. Wait till you identify all the points, press enter. Keep them scrolling on the left. There's another point, press enter. Press enter. I'll just go up. So if I was to press enter, it'll give me the coordinates of that point. So be aware, you only press enter when you get to point of interest. Escape from that. We can now tidy it up by grabbing the point so we can easily see that there's our x-intercepts. There's our y-intercept, and there's our turning point. The only other thing we will need is that vertical line, which is what you should have done in the linear equations menu 3, 1. Oops. As I say, I really do prefer using the keypad menu 3, 3, 1, 2. And remember, the coordinates of the axis of symmetry is the same as the turning point, which is 1. Remember that turning point when we did the completing of the squares? It was 1 minus 4. And that's how we go and use our calculators. With practice, this will become extremely easy. But what I'd now ask you to do is to have a go at these ones. Now, these are all quadratics, but you can see this one only has 2 terms, the difference of perfect squares. This is in factorized form. This is an interesting one. It should give you some interesting. This is already in the completed square form. And as I say, by going through those steps that I've just done, you'll be really good at it. In actual fact, I might just do one more example, but it will have to be in another video. So check that out. In the meantime, you might want to summarize or print out and paste these things into your summary book and spend the rest of this lesson just making sure you go through those 6 functions. Notice I call them F2, F3, F4, so you'll be able to try that. But I'll show it to you in the next video as well. Catch you soon.